Good day, everybody. We have a problem where log base 10 values are actually given as the roots or the zeros of a polynomial. So let's write that down by the factor theorem. If you know a zero, you know a factor is what it essentially says. So we have x minus log base 10, and the base actually doesn't matter either, as you'll see, as you probably already know. Log base 10 of a times x minus log base 10 of b equal to 0. Now, the fancy name for this, it's an Italian word, a vieta, but you can just discover, you just see this on your own without knowing what it's called. So this would be the same thing as x squared. All right, and then what you'll end up with when you expand this out, you'll end up with minus quantity log base 10 of a. And again, base 10 is not important here, owing to the change of base formula. Okay. So what happens here, these logarithms present as a sum of roots with a minus sign in front just because of the way the multiplication works out. Okay, and this is the coefficient of x. Very well known that the coefficient of the degree minus 1, if the degree of the polynomial is n, then the degree n minus 1 term has a coefficient that's equal to minus the sum of the roots or the zeros. Okay, and it's just how it is. You don't have to memorize it really. Okay, and now the minus signs cancel when you multiply, and so you have the product of the roots. Log base 10 of a, and I maybe should write it parenthetically just to remove any. Log base 10 of b. And a lot of the competitors just have this memorized, but this is why it's true. This is why Vietas is true. So there we go. And so what we can see is this 80 will be equal to log base a times, log base 10 of a times log base 10 of b. That will be equal to 80. And then minus 50, this will be minus 50 is equal to this. Okay, so let's take a look at how this might go. Now the big result here that makes it fairly easy to, and you'll see why I did all this. I probably should have written it down here, but we're going to do the change of base result because we're asked to evaluate log base a of b plus log base b of a, right? So log base 10 is not even present anymore. Okay, so we're going to do this, and you'll note that this doesn't factor nicely. I think it has irrational solutions. So anyway, there's something called the change of base formula where this becomes this. And then a little bit of algebra gives you this statement right here. People call it cross multiply, even though technically that's not what's happening from here to here. But you actually multiply these together, and you get. It's just well-known algebra right here, so I won't belabor that point. Now notice that we have the product right here, log of a, log of b, and we already know that's equal to 80, just from the original equation. Okay. Now, a little bit of algebra right here. We know that minus 50 presents as the coefficient of x. All right, so we can write this as, and I'll just write this much out. This will be minus 50 times minus 50. Okay, so that'll be minus 2,500. Minus 160. Over 80, right? So this is our answer. All that remains is just to reduce this. Let's see, I would probably choose to do it like this. Let's see here, 20, oh, this is plus, I'm sorry, plus, folks. Because remember, log A plus log B would be minus 50 from the work we did up here. Okay, minus the sum of the logs. Okay, equals to 50, which means that's minus 50 times minus 50. Okay. Now, let's see. What's the easiest way here? Since there's no easy way here. But this part right here would give 250, just breaking it apart like this, 250 over 8, right? And I'm getting just minus 2. Okay. Again, probably more than one way to do the arithmetic here. You could reduce this first, I guess. Let's see, what is that easy enough to do? 125 over 4. Right, folks? 125 over 4 minus, what are we getting here? Minus 8. Yes. So, y'all, I'm getting 117 over 4. This final answer is what I got in. Chance I made an arithmetic mistake, but the idea is very clear, and hopefully I didn't make an arithmetic mistake, but I think I got it. I don't see any obvious mistakes, unless I lost a sign somewhere. But one thing that was kind of hard for me to notice at first was that going from here to here, you're just using this, you're bringing the 50x minus 80 to the other side. If you're wondering about this, how in the world did log b squared become minus 50 log b minus 80? Well, literally, it's just bringing these two terms over to the other side. You would get minus 50x over here and minus 80. Okay, and the log is the 0, right? So that's kind of, this step right here might be considered to be something that is, that just going from log base b squared is equal to minus 50 log b minus 80. But it's just a substitution. In other words, substitution, let me write it if I can find out where my, this is just substitution. 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 However you spell that word, folks. Okay. Substitution. Maybe I got that right. Okay. So, and again, folks, what did I substitute? Just right here. Something squared is equal to minus 50x minus 80. Okay, x squared is equal to minus 50x minus 80. But the logarithm was the 0. So that explains how we hopped from here to here and hopped from here to here. Okay, there's a little bit of mystery, but it's just sometimes the things that look the hardest are just obvious. It's just you forgot that you could use the original equation to make that substitution. Okay, did I spell substitution right? Yeah, I think so. Okay, so anyway, folks, this is it. 117 over 4 is the answer I got. Let me know if you got anything different. Thanks for viewing.